Today's session, we're gonna talk about Hugging Face again and connecting it to weights and biases. So I just know how many people never used weights and biases and in what details should we go today. Okay, good. Okay, cool. And do you guys know what weights and biases is? Okay, cool. Yeah. So we'll start slow, and please let me know if I need to explain anything in more details. We are approaching kind of an end-to-end pipelines for machine learning, deep learning, basically, and tooling around algorithms that allows us to unlock a certain kind of a ability to go from training to production pretty fast. And one of these tools or libraries, depending how we look at it, it's called weights and biases. And weights and biases is a monitoring platform that allows us to monitor our experiments, save our models, and deploy them if needed. And weights and biases allows us to save checkpoints on their platforms and basically do that in basically real time. So while you train, you can save your checkpoints there. You can monitor how well the training goes in the sense of accuracy, in the sense of loss. Basically anything around the training to production to deployment is kind of covered with weights and biases. It's not the only tool out there. There is a tool or a library called MLflow that is a core of MLOps, and connecting that to weights and biases and Hugging Face creates a full pipeline that leads you from idea, training, to production that users can use that algorithm through an application such as a website, a mobile application, or something like that. And today we're going to talk about that crucial part of monitoring and saving the models to some platform, and especially when you're trying tens or even hundreds of different configurations of the hyperparameters, models, and stuff like that, you need to track that. And all of that is done through weights and biases. Let me share the link to my workbook that I'm going to follow through. And you can follow along and code along. I'm going to check with you while I'm coding, so you can follow along and basically understand that part. So just let me a second to load this. Okay. For some reason, the shareable function is not available this time. Okay, that's weird. The first things first, let's understand what is the ecosystem of weights and biases, their interface, and a pure way to integrate it in the Python code. It's a Python library that you can install by running pip install w and b, and we'll do that in a second. But before we do that, please follow the link, this one. I'm going to paste it in the chat. Okay, here it is. Go to that link and it will open the homepage of weights and biases. It's a page that this is documentation. I'm going to show that to you in a bit. But basically, weights and biases is a website where you need to register, and you can register for free. So all of the things that we're going to cover today is completely free. So you can start monitoring your experiments in no time. And once you log in, you will be at your dashboard. Now, because it's a new project or a new account, you won't have any of these elements that you see on my personal profile. See my personal profile, and you can see for some clients that I ran a year ago. So I've been using this quite a lot for my clients as well in the past. It's a really nice tool. And whenever you start with a task or a thing that you want to solve on weights and biases platform, that's called a project. So the highest tier of what we do is called a project. And this automatically from Hugging Face, I experimented before running the code for today. It created a new experiment or project called Hugging Face. And under these projects, let's open for a client. So this is for a real client of mine called Shopnosis, Serbian startup. So when I train the models from them, it will call something called runs. Whenever we have let's say an algorithm that we want to train, you will have something called a run. And one single run is basically when you run that algorithm to train it on your data. So one time on. So we have a new message. No new message. Okay. So if I open a run, you will see this. And these names, wise donkey, I didn't name these. It is automatically generated for us. And you will see that in the run itself, you will have many different graphs and statistics that it will automatically log for us. From how much CPU I used to what is the memory availability that I used at that project. Is there something that I need to check in for my memory and stuff like that? And all of this is automatically done for us. So we don't hey monitor these statistics for us. The system ones are automatically logged. Besides that, you have something called system that will tell you more about the system if there is more. Then you have logs and you have files. The font is very small. Okay, good. So let me zoom in. Thank you, Jeffrey, for that. Oh, wow. This is too big now. Wait. Okay, I think this is okay now. Okay. Good. And the log file is basically a full log of the run. You see there are images. Is there something that failed? So basically Python log automatically pushed to the web. And this is all run locally on my machine. So I didn't run it on a cloud or anywhere. I just logged it locally, and it basically connected the code with weights and biases and pushed it there. That you have files. That these files basically allows me to upload a real metadata or an algorithm if I have an algorithm checkpoint here. Because this is for my client, I didn't expose their algorithm on weights and biases. And that's basically the whole interface. So you have multiple algorithms that you can compare. Let me run to the project where I think I experimented with more algorithms, just so you can see that as well. I think this one. Yeah. Okay. You see here I used even GPU, so it monitored my GPU as well while I was training the algorithm there. So all of that is automatically monitored for us. And this is a public one, so I'll share this with you so you can experiment later on. But basically, you will have many algorithms there that I tried out to see what's going to happen if I try this specific configuration. Okay. So let me go to this one that is currently loading. Yeah. And let's open maybe this one. I think this one will have many different algorithms compared. Shahir, yeah, please let me know. What's your question?
I did have a question. So,
Yeah,
basically, this weights and biases we can. This is used to basically deploy models, is what I'm getting at right now. And you have file systems, so all of your code and all of your models will be running on this. So it is there's a cloud platform essentially as well, because it's running the models, like they're actively running in the background.
it's
Is that right?
it's not running the models. It's up to the model deployment. So you are monitoring it, monitoring in production and in training process. But you will store, let's say, checkpoints there in their system, in file system, and then connect it to maybe a Flask application or maybe ML flow that will check if there is a newer version, or for example, if you want to do A/B tests between two models, you can just ping weights and biases to say, hey, just retrieve two latest models to see which one performs better. And it's kind of a GitHub archives or Git, uh, the large files Git.
Mm-hmm.
It's
Okay.
similar to that, but it actually tracks file versions, weights versions as well, and then it will track specific metric that will filter out features or models by that metric that you set up. So more
Okay.
more related to the actual code than just pure file storage, if you know what
Okay.
I mean.
All right.
Yeah,
All right. So
that's a great question.
it's specifically looking into models, seeing how it's performing, and if we want to do A/B testing between models, we can
Exactly.
use it for that. But it's
Yeah,
it's
exactly.
it's limited to just monitoring our models. Is that right?
Yes. Yeah. Yeah. We have another question, Muhammad.
Yeah, so the models run actually on your machine or it runs on their platform?
Sorry, machine learning.
No, the model itself, does it run on your machine or it runs on the platform itself?
You can choose.
So you can like rent like virtual machines or instances where you can run your models on, not necessarily on your local machine.
Yeah.
Okay, thank you.
Yeah. You're welcome. Okay, so let's start coding with Hugging Face. We'll train a simple model. I just copied from their documentation before we start, so you can see step by step how easy it's to integrate weights and biases, and even easier to integrate it in our Hugging Face code. So import weights and biases. You initialize the project by providing a name. These are optional. Then you provide the configuration, which is basically um, set of parameters that you would like to try. And then you set up the model from any repository or local code that you can, and then train it for multiple epochs. And you basically push that checkpoint to their file storage just so you have specific version control on their platform as well. In like 20 lines of code, you can do all of that. Of course, model is not deployed here, not implemented here, but basically it's only the model that needs to be added in this code. Okay, so for today's session, we'll Davron, yeah, you raise the hand.
Uh, Luca, could you please copy paste this code on the chat, because I found the starting code from their website, but it looks different than yours.
This code is just a reference. We will implement it from scratch.
Okay.
Yeah, no worries. Let me zoom in a bit. It's not zooming in on this. Okay, here it is. Too much. It's fine. Okay, pip. We'll need to install a couple of dependencies. Install datasets from Hugging Face, then weights and biases, like this, and transformers. Okay, and just run the install process. By the way, I'm using the T4 machine, which is free completely machine with the GPU. I would recommend you to switch to GPU because the model that we will run will require more processing power to be trained. So it will require quite a lot of time to be trained, basically. Okay. While that is going on, let's talk about the dataset. So the dataset will be a really simple dataset called Yahoo Answers topic classification. So the goal for us is to classify any answer in a specific topic. Basically, that a topic going to be politics, economics, or anything else? That's going to be kind of the goal for our classification problem. Okay, we are done with installation, and you don't have to go in any link to install to take a data set. I'm just going to show you what the data set looks like on a Hugging Face platform. Go there. Okay. It's a public data set, so you can see here the question title, computers, internet, sport, health, business and finance. You have a question content, best answer, and so on. So, and you have 14,000 of those answers, and it's a public data set. The name of that is Yahoo Answers topics. So I'm going to copy this and paste it in the chat so for you to see. Okay. This is the name of the data set. Good. Now, when we talk about that, we'll have to. Okay, let me go back. Good. So you'll need to install the dependency called datasets that we did in the first step. From datasets, import load dataset. And dataset is loaded in a single line of code just by saying load dataset, and then provide the name that I pasted in the chat. You can use the full name, or you can use just Yahoo Answers topics. So let me just use the Yahoo Answer topics. Okay. And let's check out the first sample from the dataset. For some reason, my computer is lagging so much today. I don't know what's wrong with it. Okay. Can you give me like 1 minute just to switch computers, and I'll just run from my laptop because this computer is lagging too much. Just give me a second, please. Okay. So here we are. Here we go. Thank you for being patient. Okay, so let me open my workbook instead of the full file, and here we go. So the first step for us was to install the dependencies. We've done that in quite no time, but I didn't have the file saved. So we'll need to install three things: datasets, then weights and biases, and then transformers. Please let me know when you've done that. And the next step is for us to load the dataset called Yahoo Answers, topic classification or answered topics. To load that, we'll need to import from datasets, import load dataset. And here I'm going to specify dataset is equal to load dataset with a name that we provided in the chat called Yahoo Answers topics. And once you've done that, please let me know so we can proceed to the next step. Yeah. Oh, nice. Thank you. Okay. The next step for us is to check a couple of things to see how many, for example, unique topics we have in our data set. So we'll do dataset.train of maybe, let's say, 0, just to check the first sample. And each sample is called ID, topic, question title, question content, and best answer. And like right now we have this topic name, and soon we'll need to rename that to label because Hugging Face doesn't like that. It needs label instead of topic just to be able to recognize that, and we'll do that in a second. But before that, let's experiment, let's say dataset of train dot features, and then I'm going to take a topic. Okay, so I'm going to take this topic, and you'll see all the topics that we have, kind of unique topics there. And if you want to take, for example, into string 4, what it will do, it will check the 4th index of our topics file. What I meant by that, so let's say 0, 1, 2, 3, 4. Okay, and if we do this like just by regular providing 4, it will throw an error because Hugging Face has specific kind of protection, so we won't change public datasets quite easily. And there is this function called into string to allows us to actually monitor what is the ID of each topic in the dataset. Now that we have that, what we need to do is to find out what are the set of unique topics in there. So what I'm going to do is say label list is equal to dataset of train dot unique topic. And if I go and check the label list, you will see that we now have these integers instead of full strings. And I want to sort them out. And we have a list that looks like this, from 0 to 9. And if we want to check the number of labels, is equal to len of label list. Now, all of this is important for two things: to defining our custom model that we need to fine tune, and to monitor our models later on the weights and biases platform. So that's why we are preparing this right now. So all of this clear, guys? Do you have any questions? Okay. Please let me know once you of the labels. Okay, cool. So when you have a data set like this one, yes, it is hosted on a Hugging Face platform, but most people that are making these data sets, do not really care with compliance with the Hugging Face. And Hugging Face internally, once you load the data set, it does require to have features and labels names inside of our data set. And if we have a data set of train of 0 again, you will see that here we have topic 4 because we changed it from the string to integer with this one. But now we have this topic instead of label. And this topic does not provide any relevancy to the Hugging Face. And if we provide this data set as right now to our tokenizer or the model itself, it will actually throw an error. And it will yell at us and say, hey, we don't have any label. So that's why we need to rename our data set topic to the label. And to achieve that, we'll define data set with the data set dot rename column from topic to labels. And now we have our data set that is compliant with the tokenizer and our model that we'll be using. The model that we'll be using is called the Steelbird Bayes uncased, because that is the basic model just to prove that we can push any model to Weights and Biases platform. And let me open Weights and Biases platform in here as well. Okay. While we do that, can you scroll up a bit? Yeah, of course. Diego, which part do you want to see again?
No, yeah, I had an error with the unique, so yeah.
Oh, okay. No worries. Okay, I just returned to my personal Weights and Biases platform. Okay, so this is the name of the model that we'll be using for Tokenizer and our pre-trained model. So you don't have to search for that name. Here is in the chat. Okay, so now from our transformers, we need to load auto tokenizer and then tokenize our data set. That's the next step for us. So from transformers, import auto okay, and then tokenizer is equal to auto tokenizer from pre-trained, and then just provide the string that I provided to you. It will download tokenizer for us. The tokenizer generally downloads pretty fast. The model is the one that will take about 30 seconds to achieve. And if we say sample, for example, is equal to dataset train of 0, and then just take, for example, question title, and then take a look at the sample. This sample is basically the question that everybody asked. Now, if we want to tokenize this, you can run tokenizer and just provide sample. And it will figure out what is the IDs and attention masks for our sample that we need. Now, this is all well and good, but it's only a single sample. And we need to apply this to all 14,000 of our strings or pieces of our data. So let's achieve that now. Dataset is equal to dataset.map. And now the map function will take a lambda function that will run a tokenizer on top of the input. And it will allow us to run that for for the whole data set at once. And on top of that, we can define set of parameters and batch the whole process. The batching means that it will take our CPU and GPU and run multiple samples in parallel to achieve the faster, let's say, processing in this case on our data set. So to achieve that, I'm going to define lambda of x. That x is going to be a simple sample like this. It will run a tokenizer of x, and not only the x, because this is the whole this sample, we need to run it on the question title. Okay, and on top of that, we'll need to specify truncate to true. So what is this truncate? So you will have some questions that are just 10 words long, some questions that are maybe 15 words long, but then you have extremes that are maybe 500 words long, and those extremes will have a problem, will create a problem with a set of other shorter samples. So what's going to happen is this. Let me demonstrate this in an example. So you have let's say, who is this? And then you have a sample that's, I love this city so much. Do you? What do you think about it? You see the difference. And generally speaking, what these tokenizers will do, it will, of course, move each of the words to its own index like this. However, on top of that, it will do this. So this who maybe becomes 1000, then 1001, 1000, 1002, and then fill with zeros until it reached the longest sample in the data set. In this case, we have only 2 samples, so it will try to match with zeros up to the longest sample, which is in this case the second one. Now, this is not that great, because if we have this question with only 3 words, and then you have a sample of 500 words, in that case, you will have 497 zeros in that entry. So how to prevent that? The truncate to true will figure it out by itself where to cut these sentences so they don't have to fill that much information. So it will cut here. And now I need to add 1, 2, 3, 4, 5, 6, 7, 8. Only 5 zeros. Okay? So that's basically what truncate to true does for us in the background. On top of that, I'm going to specify batched to true, and it will take my GPU. Oh, truncation. Sorry, truncation instead of truncate. Truncation. It will take my data set and completely tokenize it and prepare it for our model. Okay, so this batched will do almost 500, 5,000 even at once, so we don't have to wait as long to pass all the samples in the data set. Okay. While that's going on, please let me know if you have any questions, and let me scroll up a bit so you can copy if you need to copy anything. Oh, I can slow down. Sorry. Yeah, Jeffrey, thanks so much for pointing that out. Do you want me to repeat anything that I said thus far? Here is the code. Okay. please let me know if I need to go back to any parts whatsoever, and I'm going to repeat it as many times as I need. Please let me know. Okay. Okay. Truncation. Okay. Here is the dataset processing part. I didn't proceed any further after that. Okay, our dataset is done. And I'm going to remove these two cells because we don't need them. And now it's time to load the model. Guys, do you have everything figured out thus far? Okay, cool. Thanks, Alma. The rest of you, clear? Great. Okay. So now we're going to go into the depth of the model itself. We will not dedicate that much time to the model itself or the architecture, but then we'll spend much more time on the training arguments and the weights and biases part in a bit. So we just need to load the pre-trained model, and then we need to figure out how to train our model and connect it to our weights and biases. So to load a model, we'll repeat what we did thus far with any model from the Hugging Face family. From transformers, import auto model for. Now, in this case, we are using sequence classification because we'll have a sentence, and then that sentence needs to be classified in a set of classes. In our case, we have 10 of those classes. Classification, like this. Okay, and we just simply need to run this to the model, and I'm going to copy this. And the same name that I pasted in the chat before, you need to take that and paste it in here. So from pre-trained, as we did before, and num labels is equal to num labels. Okay. This will change the output from our model to match our newly created dataset. In this case, our dataset has only 10 classes, so that's what we're going to do. And we did with the basic setup for our Hugging Face part. Now we need to figure out how to train it on a custom dataset. Before we do that, do we have any... Why does the code keep disappearing? I don't know. Jeff, like now? Like this? I'm switching between two tabs, maybe because of that. On this laptop, I don't have two screens. That I'm trying to figure it out, like how to look at the chat and the screen. Yeah, okay. So now it's time to train our model. I saw that you all have figured out thus far. So the training is pretty simple, but it does require a lot of arguments to be set up upfront. Once you've done that, you can train any model from the Hugging Face family. And the process, what we're going to do right now, is going to stay the same. The numbers will change here and there, but you will repeat the same set of steps every single time. So you'll learn it once, you're good to go. So the first step that I'm going to do is import from transformers, import trainer and training arguments. I'll explain both of these in a second. But for the first time, I'm going to import weights and biases. We install the weights and biases at the very beginning. If you run into issue and for example, your Google Colab says that you don't have weights and biases installed, please just install it with a simple pip install weights and biases, and you will be good to go. Now, before you start using weights and biases in your code, you need to log in. And you can do it by simply calling login. And like this, you're going to be good to go in like maybe 10 seconds. So what's going on is this. If you are already logged in to your weights and biases account in the browser that you're currently using, this Google Colab, it will automatically figure out from cookies that you're logged in and take Google account that you are using to check whether or not you have that account on weights and biases. And you don't have to provide anything extra, copy any codes whatsoever. This library is pretty smart on its own, so I'm just going to call weights and biases login, and it figured out by itself that I'm using my personal mail that is connected to logged in account, and that's it. So for you, you can log in to weights and biases with your newly created account. If you didn't create account thus far, please do that right now. It will take maybe a minute. And once you're done with that, you can go back to your workbook and just log in there. If these two accounts are not the same, it will prompt you to enter a special key. The special key for your account can be found on the profile. And then under your profile, let me check if they changed this interface. User settings. Under user settings, you will find how to log in. Okay. API keys, and here it is. Okay. So this is basically where you need to find your API key and paste it inside your account, inside your Python program. Right here, I won't reveal my API key because it is automatically logged in. So to repeat, go to the top right, user settings, and under user settings, you will have your danger zone API keys, and then reveal your API key. And once you got your API key, go to login, paste it there, and you will be good to go. Now, if you're logged in as I am, it's going to be as simple as just running this code cell for you. Do we have any questions? Can you go back to the part where we define num labels? Yeah, of course. So let me scroll back up. And here it is. So we define it as a label list is equal to dataset train.unique topics. I sorted out, you don't have to sort them out at all, but I sorted out and just use the len of this label list. That's it. Yeah. Here is the code. Okay, good. Nice. Okay, so in this place, we are logged in. We have our weights and biases figured out. Now it's time to set up our training pipeline for our models and push that training to our weights and biases.
Excuse me.
Yeah.
I just got my key, but where do I put my key?
I think here under login. Let me try to find that for you. API key. They changed their library quite a bit in the last month. Login. Okay. It says that they remove that part actually, and you just provide your API key when prompted. Okay, so run this code. Okay, just run wndb.login, and it will prompt you to paste your API key there. Okay, and the API key you got from the link that I just explained. Here is the API key for me, for my account.
Okay.
So just run this login, the same code as I got in here. You will get the input place to paste your API key. Please let me know if you figured out. Yeah, Jeremy just provided, not Jeremy, sorry, Jerome provided the screenshot. Yeah, input box. Thanks. Okay. So if you still have an issue with this, please let me know, and I can go back and help you with that in a bit. Yeah. The next step for us, after you all logged in, is to define training arguments. So before we go to the trainer, we need to set a training arguments. The training arguments is providing information to our Hugging Face model, how many times epochs, logging steps, maybe should we stop the training after some time. So all of that is defined in the training arguments directly, and that those training arguments are used to propel our trainer later and use all of them further. If you have grid like search or quick search or a random search for your hyperparameters, those will go to the training arguments or define multiple training arguments to test them all out. So train args is equal to training arguments, and then you provide a set of, you have so many. See how many arguments we can provide? Like they are more than 100, I think, in this. Don't worry, we don't have to specify all of them. All of those are basically optional. But the first one for us is called report to. This report to takes a string that is simply says weights and biases, and that's it. For the past 2 months, they integrated directly weights and biases into Hugging Face. And now when you train any any model, and you want to report it to weights and biases, you can just do this in a single line of code, and in the background, the starting code is immediately executed for you. They define the experiment, the project, the experiment, the tracking, all of that is done for us. Now, of course, we need to provide more arguments to it, but it's the first step that we don't have to do extra on top of that. The next step is to specify output directory, and that output directory is basically where we want to save our checkpoints while we train locally, not on weights and biases, but locally on our computer. Now we can upload that later on to weights and biases, but while we do training, all of that is stored locally on our server or our laptop or any computer that we use. In this case, it's going to be topic classification for me. You can name this whatever you like. And then overwrite output directory, overwrite output directory is equal to true. This is to true if we ran this code like before, and we have this output directory already defined, and you set this to false. What it will do, it will throw an error and say, hey, this directory already exists. So once you provide this, it will make sure that it starts from the beginning, and every time you run our training, it will create from scratch our training process. The next step is to define something called evaluation strategy. Eval strategy. Evaluation, I don't know how to write. Evaluation strategy. And that is a string called steps. So what this means is basically, okay, we have set of evaluation points that we want to define. Is it an accuracy or a loss that we want to monitor and see whether or not we improved in the training process? And this is how often we want to run these tests. Is it every single step or every single epoch? All of that is defined under here. The next step is called learning rate. Now, for learning rate, you can put any number that you like. I'm generally starting with 1 to the e to the power of -5. You can put to -4, -3. It's basically a starting learning rate, and then you can change it once you see how the training performs. Then max steps, you define to whatever you like. I'll use 30,000. Logging steps is 100. So logging steps is really, really important. This is really important to set up because this is how often we'll push the performance to weights and biases. Now, if you don't specify this, it will assume it will report at the beginning and at the end. In the middle, you won't have any reports. Now, if this wasn't integrated directly to Hugging Face, you would definitely need to define this by hand. Now, you still need to define it by hand, but at the same place where everything is defined in the training arguments. The next argument for training with the reporting is to define eval steps and save steps. Eval steps and save steps. Now, both means on how quickly, how often we will run a set of evaluations or savings. In this case, I'm going to eval our model every 5,000 steps, or save my model every 10,000 steps. So I'll have at least 3 checkpoints that I can push to the weights and biases. And 3 more, and we're done with training arguments. Please let me know, because I'm looking at this screen. I don't see your chat right now. Please just interrupt me if I need to explain anything that we covered thus far. And when I'm done with 3 more arguments, I'm going to jump to the chat, paste this all with for you, and check out if you have any questions. So 3 more arguments that are quite important are to load the best model every time we ran our training. And
Excuse me, Luca.
Yeah. Tell me.
Hi, there are a couple of questions from Salma and Adriana in the chat.
Yeah. Why did the evaluation steps is not too much for each step? Okay, that's the first. What does, okay. Would you please explain again the arguments eval strategy? Of course, great. So, and I don't know who prompted me to answer these questions, but thanks again. So the first step is, it's not testing for every single step, okay, for evaluation strategy, but it will take our steps as a kind of an argument to check how often we will test our model. So in this case, if you define this to be steps, evaluation strategy, you need to define eval steps to be 5,000, let's say in this case, but you can put 1,000 and so on. The only difference is that you must define this because you are using steps to check on how often you will perform the evaluation. Okay? basically that's it. So if you define steps, you will use this second argument to define how often. It's not every single step, but every 5,000 steps. Okay. These 30,000, you can, in Python, if you want to make it more readable, in thousands, you can put these underscores. Well, you can put underscores after each number, and Python won't read these numbers, these underscores. Okay, so it's just used to make readable thousands, basically. So instead of just putting this, I can put this, just to know that I wrote 30,000, and you can clearly see that it's 30,000 and not only 300,000 or so on. Okay. And the last question was evaluation strategy. So we want to see, while we train, are we going into the right direction? If our training process is basically to make our algorithm much better in classification of topics, we want to make sure, not at the end of the training, that the accuracy is actually good, but we will specify how often we want to see if we are moving to that right direction. Okay. What I mean by that is this. If we are checking the accuracy, we'll run for, let's say, 30,000 steps. And instead of waiting for 30,000 steps, I'm going to check every 5,000 and see, okay, cool, I'm actually decreasing the loss and increasing the accuracy. I'm moving to the right direction. Okay. So the evaluation strategy basically allows us to say, hey, please quite often check if I'm actually moving to the right direction. If I'm not, stop the training process. I don't want to continue this training because I'm not actually decreasing the loss or increasing the accuracy. Basically, that's it. Yeah. You're welcome. Thank you for the questions. And please, because I'm not seeing the chat in the real time, please let me know by voice if there are any questions, or just ask. Thanks. Okay, so last three arguments. We have this load best model at the end. Set it just to true, which is a really self-explanatory. Once the model is trained, we'll have the model multiple models, because we are evaluating, let's say, at a step 5,000, at step 10,000, 15,000, 20, 25, 30,000, and maybe our model, the best model, was at the 20,000, but we continued training after that. We just want to load the best checkpoint. So basically, forget what we learned after that, load the best model that we have. The metric that I want to follow, metric for best model, and you define it as a string, accuracy. And the last argument that we need is a run name. And my run name. Okay. Before you execute, let me explain. So load best model at the end is pretty self-explanatory. We'll have multiple checkpoints while we train. We want to make sure that it actually loads the best model at the very end. That's it. The metric for best model is how to check if we have better model than before. So we want to make sure in real time that we are actually performing better. Is it a loss or accuracy? In our case, we want to perform on accuracy point better. And that's why we have this accuracy in here. And the run name is any string that you like. This run name is the name on the weights and biases. Let me go to my profile. So you have this Hugging Face, and let me check this. You see this custom training? This custom training is the name that I just defined. So this, instead of this custom training, I will have this my run name, or any string I like. Okay? Any string here. I'll just keep this so you can visually see what's going to happen. And most of these arguments are actually setting the weights and biases in the background. And because you're using weights and biases, you're mandatory to provide all of this, so weights and biases actually works. Load best models will prevent us from saving tremendous amounts of checkpoints to the weights and biases, but only the best model. Metric will allow us to track the metric in real time on the weights and biases, in this case accuracy. A run name is to visualize on the run of the weights and biases. And these steps in here will allow us to see how often to report to weights and biases and save the progress of our training to that weights and biases platform. So I'm going to copy this and see if there are any questions. Okay. Do you have any questions thus far? Okay. Okay. Please let me know once you defined all your training arguments so we can continue. Done. Great. We have 2 more things to define and we can start the training process. Okay. Great. So because our Hugging Face by default is only monitoring the loss and not the accuracy, we need to find a custom model or custom check for accuracy, basically that. So what I'm going to do is define from datasets import load metric and import numpy as np. Now we need to define our custom metric that's going to take our predictions and report the accuracy. Okay, so accuracy metric is equal to load metric of accuracy. Now this will create our accuracy metric. Yeah, trust this code. And we basically use that. However, we need to define our function. Custom metric will take eval prediction, so our predictions, and these predictions will have 2 parts. Predictions, labels. That's going to be evaluate predictions. And then we're going to take the argument maximum to see what is the index across the predictions. Okay, so that is traditional accuracy function written in the custom metric. So here, what I'm going to do is predictions is equal to np.argmax of predictions. X is 1. And return accuracy metric that we defined in here dot compute predictions to predictions and references is equal to labels, and that's it. Pretty simple. So what we do in here, for every single sentence we'll define, because our model has 10 outputs for 10 classes. So let's say you will have 0.3, 0.1, 0.2, 0.1, 0.1, 0.1, 0.4, 5, whatever, okay? And what argmax does is checking what is the highest value and then returning the argument. So this is 0, 1, 2, 3, 4, 5, 6, 7. The output in here will be 6 because this is the highest value and the index of that highest value is 6. And this accuracy metrics will check those predictions after argmax and then check if those are actually correct to what we want as the accuracy, basically. And that's it. Please let me know if I need to repeat something from here and if you have this copied. Cool. Great job. Okay, we are close to training. The final step for us is to define a trainer. That's going to be our trainer. And the trainer will take 1, 2, 3, 6 arguments. The first argument is the model. We defined our model in here. Then the second argument is called args. And those arguments will be our arguments in here. Okay? The third argument is a training dataset of train. The eval dataset of test. Then tokenizer is equal to tokenizer that we define at the beginning, and then compute metric is equal to our custom metric. And that's basically it. Once you define the trainer, you're good to go. What? Compute metrics with multiplication. Okay. And that's it. So this trainer will take your model arguments, data set for evaluation and training, our tokenizer that we defined far before, and compute metrics that we define a custom so we can follow the accuracy as well. And the funny story is, not the funny, but interesting thing is, all of this is tied together back to weights and biases because we use the training arguments and defined all of these training arguments to be visually accessible through weights and biases and their archives. So all of that is happening once we start the training process. So trainer.train and just start. It will take about half an hour. We won't, of course, wait half an hour to to basically see that. But an amazing thing is this. Take a look. You can see the project Hugging Face. You can view the run in here, and I'm gonna click on this run. Okay. It will go to my Hugging Face weights and biases connection and see the run in real time called AnyString here as I promised. And you will see training epoch, grad norm, learning rate. We started from here, moving to there, training loss, global step, all of that happening in front of us in real time. Okay, if I refresh this page, you see now we moved here. So all of that, once we define our training arguments, all of that is tied in here. For you guys that need to copy this, please, here is the code for that. And bam, we have in real time monitoring our training of our full-fledged NLP model on our task. Yeah, amazing. You see CPU utilization later on, because this is done through cloud compute on the GCP, and they are reporting that with kind of latency. So we'll receive this information as well in the future. When I say future, like 15 minutes, but not in real time. Yeah. Artifacts, you see this? Manifest, so that's basically our arguments. See this? All of that, like what is the size of the model, what is the stage, all of that is defined for us. Artifacts, model, we have our model in here. The full model, base model, latest, V0, any string, what is the size, comparing two models. Yeah. Okay. Do we have any questions? I guess no questions. Okay. See, this is currently running. 2 minutes or 3 minutes ago created, so all of that is there. Like, see this? Accuracy, accelerate with the GPU. What are the parameters? Like, what is the architecture? You see this? The still bird that we define in our code with the simple string. Okay, so we just defined that. All of that is created and reported in here. So as I said, you can compare multiple runs. Okay, I don't want these filters. Okay, and you see this? All arguments for our model architecture is defined in here. And if you change anything in your Hugging Face, it will be reported in here. See how many things are just there for us without needing to specify any of these. And if I go to my run, let's go into the current run. See the training loss is going down. Learning rate is there. Grad norm is amazing, so it's fine. And all of that is reported for us. My code is not running. Okay, cool. So I'm getting the next steps is given. It will override. That's fine. It's not the error. It's just a warning. You see this? I think I got the same. See this? It's completely okay. Can I use it with other models like neural network? Yeah, this is a neural network, Salma. Yeah, we are using a really complex neural network called BERT. It's a transformer-based architecture. Yeah, and Jerome, you have having some trouble with the connection to weights and biases error. You must call init before log. Okay. Okay. So that's weird because it should be done for you automatically through training arguments. So make sure to rerun. Go to file or file and restart runtime, sorry, and restart your session. Make sure to do that before. Then before you execute any of these steps, training arguments and stuff like that, make sure that you just log in with weights and biases. Provide with your API key and you'll be good to go. So after you log in, it will prompt you to provide API key. You do that. Please make sure that you are done. You don't have to do anything extra like these steps. They're not needed for us. And you just execute the training arguments that I provided to the chat, and the rest is basically load metric and then just trainer. So you don't need to specify any init, and yeah, the init is specified when you go fully custom. This is done through Hugging Face, so you don't have to do it. Yeah. Oh, sorry. Yeah. Jeffrey, can you copy and paste the error that you're getting right now? Okay. No column in the data set. Format signature. Okay. Okay. That means that yeah, of course. I think that is due to the beginning of the model. But let me share my full notebook with you guys, so you can see every single step and then compare offline as well. And which part, Diego? This part in here, or this part?
Let me see. So I think I have a problem. I think I have a problem in the label list.
Sorry, in
The label list.
label list. Okay, so let's handle that. This one?
There you go. Yeah, label list equals features topic.
Please make sure that you're running this to string.
I
of
did that
4.
part, but I think I have a problem with it. But next, give me a sec. Unique topic. Okay. Let me try again.
All good? The rest of you guys, can I help you resolve some of the other issues? Jerome, the error that you're getting is definitely due to login. And just restart your run and you'll be good to go. Our accuracy is not at all bad. We have 67% accuracy on a 10 classes, which is amazing. Okay. Rerunning got rid of that error, but I'm getting the authentication error. I think it has to do with weights and biases defaulting to a corporate account instead of... Yeah. If you have a corporate account, this wouldn't work because you need to have a permission by the corporate. I had the same issue with that. And unfortunately, I think the best way is to change the browser that you're currently using. So for example, I'm on Google Chrome and I'm using Safari as a default. For example, I'm gonna switch to Opera or Chrome instead for the personal one because of that bug in weights and biases. So Mohammed asked, does it save a copy of the trained model on the weights and biases or just local machine? By the default, it's only saving on the local machine in the folder that we defined. You see this, weights and biases and topic CLF, which is our checkpoint, as you can see here. But you can simply, by the end of the training, you can simply push that artifact to weights and biases and save it there. So you can save the checkpoint there as well, not only on the local machine. Yeah. Why does the train grad norm fluctuate so much? Could you explain what might be happening during the training that causes this behavior? Yeah. So because of that, we moved to fine-tuning immediately, and not we didn't perform the transfer learning before. And because of that, the gradients that updates the whole network are definitely all over the place because of the new data set. So if we want to prevent that from happening, what you do is basically define a final layer, which we did, but we didn't perform the transfer learning before. Thus, gradients coming from the distribution of data will completely change the interiors of not only the final layer, but the whole network as well. And that causes the fluctuation. To prevent that and normalize that as much as possible, you would perform the transfer learning before, so freeze the network, train the last layer only, or last two layers, train it, and then unfreeze, and then fine-tune what we did. And by doing that, you will normalize the gradients coming from the last layer, and you will normalize the whole training process. Yeah. No, thank you for the question. Okay, I copied the link for the Google Colab with the full code. I'll copy that in the comments of this session as well, once the link is up and running.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.